So on page 73, speaking of distance, rate, time word problems that I did in the last video, we have one right here. So remember, we're using two variables now. We're going to set up a system of equations. So we're going to write two equations using x and y and solve them by whatever method we decide to choose. So this is distance, rate, time. We're going to go ahead and make a chart. So let me go see if I've got what color I got going over here. All right, so the chart is going to be familiar to you. I hope you've already read the problem because I'm going to just start filling this in. There were two parts to her trip. The first part was at, and let me go ahead and put the labels in here. So this is your rate, and this is in miles per hour. This is your time, and it's in hours. And then this is your total distance. Distance equals rate times time. And this is in miles. Okay, so the first part of her trip, she traveled at 24 miles per hour. We don't know how long that part of her trip was. We're going to let that be the variable x. The total distance that she would have covered during that first part of her trip at that rate is rate times time, 24x. Second part of her trip went a little bit faster, 30 miles per hour. We're going to let that be y, and the distance covered there is 30y. Our last line, our total y, we know the total time was 2 hours. And we know the total distance was 56 miles. So our chart's filled in. Now we've got to go set up two equations. One equation is going to be based on time. You add these two times together, and this needs to equal 2. So that's a pretty straightforward equation. The time spent on the first leg plus the time spent on the second leg equals 2 hours total. The second equation is going to be based on distance. These totals are important because this gives us our equal sign, what goes on the other side of our equal sign in our equation. So we know that the distance that she covered at 24 miles per hour plus the distance that she covered going 30 miles per hour is equal to a total of 56 miles. So here are our two equations. We could choose substitution, but I'm going to choose elimination just to give you a little bit of a practice with elimination to solve. So I'm going to multiply this nice, easy equation. I'm going to multiply through by negative 24. That's going to cause my x terms to cancel. So minus 24x minus 24y equals minus 48. And then I'm going to stack it right above the equation that has to do with the miles. And I'm going to add these guys together. So like I said, that was my whole goal when I eyeballed what I could do to get rid of one of these variables. And that's why I multiplied by negative 24. What do I have left over here? 6y equaling 8, or y is equal to 8 over 6, which reduces to 4/3. Now remember what y is. Y is time, and time is in hours. So this is 4/3 of an hour, and we'll come back and put that in hours and minutes in a second. So we've got y. We need to go find out what x is. So if we come back to the x plus y equals 2 equation, and we plug in 4/3 for y and solve for x, that'll go pretty quickly. You do have a fraction, won't bite. If you have 2, that's the same. If we turn that into thirds, that's 6 over 3. So 6 over 3, take away 4 of those thirds, and you end up with x equaling 2/3. So in order to answer the question, we've solved all this. Therefore, the answer to the question is 4/3, this guy, of 60 is 1 hour and 20 minutes. 1 full hour and 20 minutes more at 30 miles per hour, because that's what y was, 30 miles per hour, and 2/3 of 60, which is 40 minutes at the faster speed. Oh no, that's the slower speed, at 24 miles per hour. And that's how you do it. So why don't you go ahead and, like on the page before, just set up example or part B of this example 2, set up the chart, create your equations, and apparently you don't have to solve it. You can just set it up, do not solve, and I will see you back next time. Bye-bye.